So here we can see that metakaolin and RHA imparts lower water absorption as compared to the other mixes. Further, resistance to sulfate attack uh, in 2006, Al-Akhares studied the sulfate resistance of concrete, and it was concluded that it increased with the increasing level of metakaolin. Due to high fineness of metakaolin as compared to OPC, and it acts as the pozzolanic material, and which increase the packing density, and the pore refinement was takes place. In 2014, Ni et al. Studied the expansion of fly ash GGBS incorporated mortar samples in aqueous sulfate solution, and they have concluded that resistance to sulfate attack was reduced as compared to control specimens. Even it was higher than that of sulfate resisting cement, as we can see in the figure, that here the expansion, that is length change percentage, was here for OPC, and this is for SRC, and here this is for fly ash and slag. So we can conclude here that the length change is quite less than that of SRC when we will incorporate the fly ash and slag. Similarly, in 2009, Chatavira and Lertwan Rook studied the strength loss of mortar, and they have concluded that strength loss was increased after 0 to 50% replacement of black rice husk ash with OPC under MGSO4 attack. But reverse trend was observed under sodium sulfate attack. Regarding chloride penetration resistance, Khan in 2002 studied the PFA inclusion, and it was concluded that chloride penetration resistance was increased as compared to normal concrete. In 2009, Ramjaniapur et al. Studied the inclusion of rice husk ash from ranging from 0 to 15%, and it was concluded that lowest chloride permeability was observed at 15% RHA, and so and so for different authors, different researchers studied, but and the final conclusion was that chloride penetration resistance was decreased, as we can see here in blue colored font, by increasing level of different SCM materials such as POFA, RHA, slag, and like GGBS at different water cement ratio ranging from zero point 0.4 to zero point 0.6, as given in figure 1. Like here we can see that this graph is for control PC, and this is with the replacement of 50% GBS, and we can see here that total charge passed in coulombs was quite less than that of control samples. Likewise, ASAS in 2012 studied the chloride penetration resistance of concrete by incorporating silica fume, and it was silica fume and fly ash. This is for silica fume and this is for fly ash, and it was concluded that uh, at all water cement ratio, here we can see in this oval that the silica fume incorporated concrete have much higher chloride penetration resistance than that of fly ash and OPC, as because this was due to that silica fume has higher fineness than that of fly ash. So the chloride ion penetration resistance was more in case of silica fume incorporated concrete than the two others. Regarding carbonation resistance, Dua et al. In 2013 studied the depth of penetration of carbonation, and it was concluded that the depth was increased with SCM contents, as we can see here, and also with age it was increased, and we can see here also here that with the addition of SCM, CH content was reduced, and which imparts the acidity in the concrete, and the pH lower down, and therefore carbonation resistance carbonation pH lower down, and therefore SCM filled pores and thus less CO2 intakes. In 99, you et al. Studied the carbonation depth of concrete, and it was found that with 30% of RHA, carbonation resistance was reduced. As we can see here, the carbonation depth was less for GGBS metakaolin, and then that of GGBS and normal concrete, that is control concrete. Regarding freeze thaw resistance, in 2014, Ajhabaglu et al. Studied the compressive strength loss after certain freezing and thawing cycle. As we can see here in figure, this is in figure 1 and figure 2, and they have calculated the weight loss and compressive strength loss, and it was conclusively uh, uh, withdrawn from these two graphs that compressive strength loss was 26%, 18, 11, and 7% for control fly ash incorporated silica fume and metakaolin mixtures respectively, while mass loss was uh, 1.36 here, 1.36, 1.05 here, 0.70 here, and 0.48 percentage here. In 2002, G et al. Studied the freeze thaw resistance of SCC containing ultra polarized fly ash, and they have concluded that under freezing thawing cycle, SCC performed better with ultra polarized fly ash than that of controlled without ultra polarized fly ash. Like in like that in 2008, Yajiki performed the test under freeze thaw conditions, and they have it was concluded that compressive strength and split tensile strength uh, was higher than that of controlled concrete, and at all replacement level, the compressive strength and tensile strength of fly ash and silica fume incorporated SCC, and which were called HS rich samples, were more than that of S rich sample. As we can see here that this graph is for H, this graph is for HS rich, and this is for H rich, and at 40%, the residual compressive strength was more uh, at 40% fly ash, and this is residual compressive strength at 0% of fly ash, that is for controlled. And in case of tensile strength, um, this is maximum residual strength. So at 30% fly ash content, the residual split tensile strength was higher than that of controlled. This is for control with the 0% fly ash content, and which was due to the extra curing effect uh, causing by sodium ions. Regarding alkali silica reaction, Thomas in 7, 11, and Afsinia and Porossi in 2015 studied the alkali silica reaction, and they have it was concluded that the presence of SCM, uh, uh, the expansion due to alkali silica reaction was reduced, and like Thomas concluded that at later age, concrete with high fly ash content has more resistance to ASR, and when the replacement level was increased from 10 to 60%, expansion caused by ASR was decreased irrespective of fly ash composition. Like here, we can see that with a higher replacement of fly ash, the alkali silica reaction was reduced, and here the chemical composition was also different. So for FM mix, that is lower calcium oxide content, the alkali silica reaction expansion was lower than that of other mixes. In 2011, it was concluded that at higher replacement level, different SCM such as silica fume, fly ash, GGBS reduced the cracking due to